Back in business. All right, last lesson here of the year. I've been trying to preach this to you. All right, it's the last one of the last little segment here of the year. Try to figure out what type of graph you're going to have before even graphing it. And I think that'll help you out big time, especially with today. So we've graphed 3 so far. 3, a circle, which could be what? R equals basically any number, right? That could be any number. Or it could look like this. R equals 3 cosine or sine theta. Just a number multiplied by sine and cosine. You know that's going to be a circle. Then we came to the heart graphs, the cardioids. That's going to be something where 2, now this could be also a minus. I'll put plus or minus 2 sine theta. I know it's going to be a heart or a cardioid when those two numbers match. Only time they have to match. And then this is what a couple of you guys struggled with yesterday with the Lima sign, the loop within a loop. That's when the numbers are different. All right. So before you guys, I want you guys to get in the habit of, hey, even before I start plugging numbers into my calculator, I know what this should end up looking like. Because today your calculator is useless, unfortunately. So we have to recognize, oh boy, this is one where I can't use a table or my calculator. So I want you to be familiar at least with these 3 here. Oh, that's going to be a circle. Oh, that's going to be a heart. Any questions about those 3 before I get into the new one today? All right, the new one today is kind of like the circle one I have up here, but there's going to be a number plugged in front of the theta now. All right, so go to the first one I have for you on day 7. Does everyone see the 2 now plugged in? All right. Just to make sure we're good, I get rid of the 2. What's that going to end up? Don't get rid of it. What's it going to end up being? That should be a what graph? Just if I just say it's 4 sine theta, you know that's going to be some type of circle. Since it's sine, probably on the y-axis. All right, but now I'm going to add the 2 in there, and now my calculator and your table is useless. This right here is called a rose curve. When I have a number in front of theta, this is a rose curve. You're going to have petals now. So I'm not saying it's going to look like this, but we're going to have a nice little graph looking like this now. All right? Hopefully you don't do it as bad as I did there. All right, but that's what a rose curve is, petals. And here's why. Let me just show you why your table's useless. Don't even fill it in. I'll fill in my table with the values you would end up getting. Here you go. Watch what happens here. 0, 3.5, 3.5, 0, negative 3.5. Basically, here you go. You're going to be graphing this. Back to 0. Back to 0. 3.5. Back to 0. Like, what are we graphing? No, I don't think so. That's not what we're graphing. So that's why your calculator is useless. You're never going to get a correct graph out of that. So we have to remember some rules today. A couple simple rules. Number 1, identify this is going to be a rose curve. You're going to have petals here. Number in front of theta. All good. I know I'm going to have petals. Here we go. Let's start writing down some rules now. Number 1 is you got to determine how many petals am I going to have. So number of petals. All right. How many petals am I going to have here? That's all determined by the equation. Ready? You look at the number in front of theta. Even or odd? Even. So if it's even, if that number is even in front of theta, the number of petals will be 2 times that. All right, so if even, which it is, it's going to be 2 times, in this case, 2. So we're going to have 4 petals. So if that number is even, you multiply it by 2, and that'll tell you how many petals you should end up with on the graph. What if it's odd? I'll get to that in the next graph. All right, but for now, just worry about if it's even, I multiply that number by 2. I double it, and that'll give you the number of petals. Next, how far apart are they? How far apart are these petals going to be? All right, I got 4 of them. They have to be equally spaced. They have to be equally spaced apart. So now, how far apart? You take 360, because I go all the way around, right? And you divide by how many petals you're going to have in this graph. So I take 360 and divide by 4. Each petal will be 90 degrees apart. So once the first petal is formed, I go 90 degrees, make a new petal. Last thing, and there's only 3 things you need. How many petals? How far apart are they? And then finally, where to start. You know, because you're not always going to start at 0. All right, so where to start? And I told you there's a little bit of a rule here. Is this a sine or a cosine curve? Sine. So if it's a sine curve, you start halfway in between how far apart they are. All right, so let me say that again. If it is a sine curve only, you start halfway. So they're 90 degrees apart. You start halfway how far apart they are. So we're actually going to not start at 0 degrees. We're going to start at 45 degrees. Okay. And now we'll put it all together on the graph now. So I know I'm supposed to have 4 petals 90 degrees apart. The first petal will start at 45 degrees. Ready? All right, go to your curve now. Where's the first petal going to start? 45 degrees. Now I know it's in radians, but who cares? You guys know how to go in degrees. It's separated by how many degrees each time? 15. So everyone find where 45 degrees would be. I don't care if it's in radians, just where's 45 going to be? 15, 30. So it's going to start somewhere at pi over 4, right? That would be 45 degrees. Everyone all right on how I got there? All right, now what do I plot there? You plot how far the petal is going to go out. And that is the first number. What's my first number in this curve? 4. So at pi over 4, 1, 2, 3, 4. That's how far the petal is going to go out, whatever that first number is in the equation. Last thing we need to do, and then it becomes cake. How wide or narrow is this petal? Because I can't just have you guys, all right, let's do that. All right, well, what if it's a little bit skinnier? Huh? We don't know. So here's how you find out. Now you can use your table. So what I need you, or you don't need to, what I need you to do is you check the angle to the left and the right and see what that value is. So everyone grab your calculator right now. Let's do the one to the right. Everyone plug in pi over 6. So 4 sine 2 times pi over 6. And let me know what you end up with. So everyone getting about 3.5 if I rounded? All right, so go ahead and graph 3.5 on pi over 6.
Wait, what did you do?
Okay, ready? I don't know how wide or narrow it is, Jared, right? So I need to check that on my calculator. Yeah. So I went to the right, which was pi over 6, plugged that in, see what my value was. So I, just like we did yesterday and the day before, 4 sine 2 times pi over 6. And everyone should be getting about 3.5. So graph that. So at pi over 6, 1, 2, 3.5. Go do the one to the left now, pi over 3. And you're going to see we don't need to do this every time. Plug in pi over 3 now, the one to the left of it. And what do you end up getting? Same thing. And that's going to happen every time. All right, so I get 3.5 here. So now we can confidently make this petal. So here's our first petal. I start at the origin. Come on up. Come on up. And watch how fast. How many petals are we supposed to have again?
4.
Watch how fast the final 3 go now. Because we know everything. We know everything. All right. Next petal. How far apart are they? How far apart should each petal be? What did we determine? 360 divided by 4, they should be 90 degrees apart. So from pi over 4, aka 45 degrees, I need you to go 90 degrees now. 15, 30, 45. Remember, they go by 15 degrees. So find where 90 degrees would be right now away.
There.
Find where 90 degrees would be.
Pi 2.
All right, hold on, Tim, hold on. It should be at 3 pi over 4. Is that 90 degrees away? Everyone's getting that? Okay. Everything's going to stay the same. How far out should it go? How long is the pedal? 4, right? So at 3 pi over 4, I go out to 4 again. 1, 2, 3, 4. And take a wild guess. You don't even need your count. Guess what's going to be to the right and the left? 3.5. Okay, 3.5. All right, go 90 degrees further now. So at 3 pi over 4, increments of 15. Go 90 degrees further, 5, 15, 30, 45. Where do we end up? Anybody?
5.
Next pedal should start at
5 pi divided by
5 pi over 4, still a length of 4. 1, 2, 3, 4. To the right and the left. 3.5, 3.5. And finish this bad boy up. 90 more degrees. And that one should be at 7 pi over 4. Three and a half on each side. All right. Anything you want to ask? Because basically the rules are going to stay the same. There's going to be one change on the next problem. And that's it. Anything you want to ask? Go ahead. We got one more. All right. 4 cosine 3 theta. First question, number of pedals. All right, now what do you notice about that number in front? It's not even, it's odd, right? So if it's odd, that is how many pedals you have. Even, you double it. Odd, that's how many you're going to have. So we're going to have 3 pedals here. Okay, 3 pedals. If it's odd, that's how many you have. All right, next, how far apart are they? Same way we found out in the last one. How do I figure out how far apart they are? I take 360, divide it by the number I have, 3. 120 degrees apart. Here's where the change comes in. Remember last problem, it was a sine curve. Now it's cosine. So instead of starting halfway in between, I start right at 0 every time. Cosine always starts at 0. Okay? Sine starts halfway in between. All right? Cosine curves, cosine pedal curves always start at 0. And then I go from there. All right? Always start at 0. So cosine always start at 0. All right, let's do it. So start at 0. Look back at your equation. How long is this pedal?
4.
4 again, right? Because it's the number out in front. So go out to 4. 1, 2, 3, 4. Ooh, now we got to look to the right and the left to see how wide or narrow it is. Nothing's labeled there, but darn it, you know what's there. What do they go by in radians? Pi over?
Pi over.
What's it go by? Pi over what in radians? Nah.
6.
Come on, 15 degrees. It goes by 15 degrees or pi over, thank you, goes over pi over 12. So this one below it would be 23 pi over 12. So go ahead, plug in those numbers. Bless you. plug them into the equation and see how wide or narrow we got to go here.
2.8.
Why is it 23?
Because remember, Jay, I go all the way around. There's 24 of these.
Oh, okay.
So one below would be 23. All right?
Yep.
2.8. 2.8. All right, so go about 2.8 on each side. 1, 2.8. 1, 2.8. And there you go. There's your first of 3 petals. Let's go. Next petal. 120 degrees away. Go by 15s. Start at 0. Go by 15s. Where's 120? Because that's where petal number 2 is going to go. Let's finish. Let's finish. So if you go 120 degrees, where are you? 2 pi over 3. So at 2 pi over 3, everyone should be going out to 4. You don't even need to check. You know it's going to be 2.8 again on each side. And then go ahead, find your last petal. 120 degrees away from that one. And remember, you're just counting off by 15s.
Wait, why are you going out? Oh, I get it. Very much.
What?
Where's that last petal going to be?
204
pi over
4 pi over 3 should be that last petal. 1, 2, 3, 4. 2.8 on each side. Toughest thing is knowing it's a rose curve and then remembering your rules, because calc's probably not going to help you too much. Any questions? All right. Looks like back to business on Tuesday, huh? Enjoy the weekend. Nothing stronger than ginger ale.